Welcome back to my channel, everyone. Tips here, and today what we're going to look at is I've got one of my stock pots here. I think I started this in May of 2021, and it's almost October of 2022. So what we're going to do is we're going to try to process this stock pot for the precious metals that it contains. The stock pot receives all of my gold refining waste. If you look down in there, you'll see that there's some mud on the bottom of the stock pot. That is precious metals that cements out from the gold refining waste that I add to this stock pot. It's full of copper. Any traces of precious metals in the gold refining waste, usually platinum group metals, gets cemented out on the copper. So now what we're going to do is we're going to empty the contents of the stock pot into a clean beaker. There you can see the mud that's accumulated in there. Let's see if we can rinse this mud down into the beaker. That black mud is going to be a little bit of gold, a little bit of platinum group metals. There's going to be pieces of copper in there. Looks like a lot, but when we get it down and get it refined, you'll see that it's not going to be all that much. Alright, I've got a beaker here, and what I'm going to do is reach down in here and pull out these pieces of copper that are left over, and we'll add these big pieces to my active stock pot that I have currently cementing out metals from my gold refining waste. Try to get some of that black powder down into our reaction beaker here. Matter of fact, let's take this. Now let's pour the copper back in here. And we're going to pour some of this liquid back into the stock pot. All I want is the solids down on the bottom here. That's the stuff we're going to work with right there. Okay, I've got a couple pieces of copper here. Put this down inside of the stock pot. I've got my gold refining waste in this temporary waste container here. So what we'll do is we'll add this gold refining waste to the stock pot. It's going to have traces of precious metals in solution, mostly platinum. And down at the bottom there, you'll see we've got some gold that's accumulated in the bottom of this container. And probably the next video we do will be getting the gold out of this waste container. For now, I'm just going to pour gold refining waste into my stock pot. Alrighty, and then there's the gold that's left down at the bottom, down here. I'm going to put the date on here. I think today's what, 17 September 2022. Put a cover on this and get it out of the way. All right, here's our solids out of the stock pot. It's going to contain some copper, some gold, some platinum group metals, probably mostly platinum, hardly any palladium. But to begin this, what we'll do is I'm going to add some distilled water to this. Alright, that's distilled water going in. Now what I'll do is I've got some nitric acid here. To measure out about 60 milliliters of nitric acid. Dump that right on in. This will dissolve out the copper, and it should get out the any palladium that may be present. I don't expect a whole lot of palladium, but we're just going to let that react off the heat for a second. Now let's put this up on some low heat and let this heat gently to remove the copper from those solids. Here you can see the solids are on the heat, on low heat, with some dilute nitric acid. We're starting to pull the copper out of there. The solution's turning blue, so we'll go from here. I've had these solids gently boiling in dilute nitric acid for about the last hour. And so now what we're going to do is we're going to pull these down off of the heat and just let this cool off and settle down and take a look and see exactly what we have before we proceed. I'm going to dip a piece of filter paper in here and do a stannous chloride test and see what we got. In solution, the solution appears green and blue. And I don't see a whole lot of reaction going on there. Not a whole lot of precious metals indicating on there. So we probably just have a bunch of copper in solution. I've got a light here, and if you look down at the bottom of the container down there, you'll see we've got a layer of solids down there, and the liquid up on top of it is a green color. So what we're going to do, I believe, is I've got a vacuum bottle set up here, and what we'll do is pull this solution off of those solids with a vacuum bottle. All right, I've got my vacuum bottle hooked up to my vacuum system. Now we're going to start pulling the solution off of the solids here. All right, I think we got most of the liquid off of there now. Here's our solids down in the bottom of our beaker. And I think what we're going to do is continue with another dilute nitric boil and keep doing that until we get all the color out of here. Gonna add a little bit more distilled water. I'm gonna measure out a small quantity of nitric acid here. Let's add about 40 milliliters. Add that right on in. Got a nice reaction going there. So we still got some stuff reacting with the nitric acid. Fairly vigorous. We're going to put this up on the heat now and gently heat it to see if we can remove some more of the base metals out of there before we proceed to the next step. This has been on low heat now for about 10 minutes. You can see the solution is blue in there, so we're still pulling some copper out of here. And we'll just let this cook gently on this low heat until we clear all them fumes out of our reaction beaker. We've been on boiling now for about an hour. All the fumes have cleared up in here. Let's pull this down now and let it cool off. It's been allowed to cool for about 20 minutes. Here you can see a definite layer of solids down on the bottom of the beaker with a blue liquid up top. So now what I'm going to do is we're going to go ahead and draw off the liquid out of here, get it out of the way. I'm just going to keep doing this. All right. Here's a look at the solids. Still see a lot of blue down in there. Blue tells me that we still got copper. So what we're going to do now is add some more distilled water and do another nitric boil on this. I'm going to add a little bit more nitric or distilled water. And now I'm going to add some more nitric acid. I've already got some pre-measured here, about 50 milliliters. We'll go ahead and add this in now slowly. Set this back up on the heat and continue to let that react in our beaker. This is looking pretty good. The solution gets a lighter blue color with each of these subsequent nitric acid boils. All the fumes have dissipated in here. And so what we're going to do is pull this down, let it cool off, and then draw that blue liquid off of there. Here you can see that the layer of solids on the bottom is getting smaller and smaller. I'm still pulling blue liquid off of here with these nitric boils. And I'm just going to keep doing this until I get a clear solution sitting on top of the solids. Okay, we're pulling blue liquid here, and so I'm not concerned about having any precious metals in that blue liquid. I'm going to add some more distilled water here, and I'm just going to keep doing this until I get all of the copper pulled out of here. The amount of solids is getting smaller and smaller. Now what we'll do is add a little bit of nitric here. That's about 20 milliliters. I'm going to add that right on in. And we'll set this back up on the heat now and let this continue to react with that nitric acid. This has been on boiling now for about an hour. I'm going to take this down off the heat now and let this cool down and see what we got. I've let the solution cool completely, and if you look down here, it's looking green now. So what I'm going to do is reach down in here with a piece of filter paper. We're going to get a stannous test on this. I think we're pulling some precious metals now. I got a little too aggressive with the nitric acid boil. Turn the heat up a little bit on it, and the nitric, I think, has put some precious metals in solution, as you can see by that stannous test. Looks like platinum, and you're probably wondering, how did boiling dilute nitric put platinum in solution? I've seen boiling dilute nitric acid put platinum, gold, and palladium in solution. So I think what we've done here is we've put a little bit of the precious metals in solution. The solution is still green, so it's probably got a little bit of copper in it. And what we're going to do now is decant this liquid. What we're going to do is tilt the beaker a little bit here, carefully. And now I've got a clean beaker. And I'll start pulling the solution out of here, one dropper at a time, since it's got such a small amount of liquid in here. I've got all that liquid drawn off. I'm going to add a little bit of distilled water to the solids again. Here we go. We're going to add a little bit of nitric acid again. Just a little bit, maybe 20 milliliters. I'm going to pour that right on in now. And now we'll set it back up on the heat. gently heat it this time without giving it too much heat and boiling it strongly like we did with this liquid. It's going to be mostly platinum, and the green color's probably from some of the copper that we're still pulling out of those solids. One more nitric boil, then we'll proceed from here. This has been on boiling now for about 15 minutes. I'm going to take it down off of here and let it cool. The longer we let it set up there and boil, the more platinum is going to try to dissolve. So we're going to take it down, let it cool, and go from here. This has been allowed to settle completely and cool off completely. Going to get down in here with a piece of filter paper. Notice that the solution still looks a little bit green, but it's not dark or vivid green like the first extraction that we did here. Let's get some stannous on this and check it. And I'm still getting a little bit of a stain going here. It's looking kind of green. All right, the goal here is to get this solution, or get the solids rather, cleaned up and ready for the next step, which is to dissolve the solids in Aqua Regia. So what we're going to do here is go ahead and pull the liquid off of here just like we did earlier. Here's a look at our solids. It's looking pretty good. And the goal here is to get these black solids down here cleaned up and free of copper, so that we can go ahead and put this stuff in solution with some Aqua Regia and proceed with this refining. I've added some distilled water here, and now what we'll do is we'll cover this up. I'm going to set it back up here on the heat, and we're going to boil this now in some plain distilled water and go from here. It's been on boiling in plain water now for about half an hour. Let's take this out. We're going to set it down here and let it cool off and see what we got. I've allowed this to settle and cool completely. If you look, looks pretty clean. Maybe just a little tint of color on it still, but the black solids are sitting on the bottom of the beaker, and it should be pretty clean except for that junk precipitate sitting on top of the black solids. So now what I'm going to do is I'm just going to remove this now, get it out of the way. Next, I have this liquid that we removed, the nitric boils from our black solids. And if you look, you'll see we've got a little bit of precious metals in this solution. Not much, but a little bit. Turns the The Stannis test turns the filter paper a slight orange and brown color there. So this liquid's got a little bit of precious metals in it. But for right now, I'm just going to set this up and get this out of the way. We'll work with this in a little bit. The third component here is our blue liquid that we have in our vacuum bottle here. And I believe that is just mostly copper, but it may contain traces of precious metals. So what I'll do is add this blue liquid right back into the stock pot and let any traces of precious metals that might still be in there cement out on the copper in that stock pot. These are 3 additional items that I'm going to add in to the black solids that we've got cleaned up from the stock pot. These are the mixed black PGMs from my anode filters, and it's got a little bit of blue material floating on top of that because I submerged it in water to store it. So we're going to work on this and try to incorporate it into this refining. So what I'm going to do now is add it to this beaker. These are the mixed black platinum group metals that we got from the anode filters video here a couple of months ago or so. And I did not process it separately because there wasn't enough material here to do a complete refining on it. I've added some distilled water to the mixed black PGM powders in this beaker. And what we're going to do now is add a little bit of nitric acid, just a few squirts, to pull any copper that might still be in here out. And this is going to have palladium in it, so palladium is soluble in nitric acid, so this will tend to pull the palladium out of this solution as well. Give this a little swirl, and now we're going to set this up on some low heat and see what we can pull out of here with this dilute nitric acid. These 2 compounds in here, this is some platinum group metals that precipitated out when I added SMB to the solution and precipitated out the gold with the SMB. I allowed this solution to set overnight, and the next morning I had a whole bunch of black mixed PGM powders in the bottom of this beaker, so I just dissolved it in Aqua Regia, and that's what this is. It's going to have some mixed black PGM powders and some gold in it. That was from my filter papers refining video that I did recently. That's what this material's from. Also, in that video, the filter papers refining, I had some platinum salt that I precipitated out. I think I used ammonium chloride, and that's what this is, a little bit of platinum. So now what I'm going to do is I'm going to add this carefully to the beaker here. Platinum salt. I've added the ammonium hexachloroplatinate in that filter down to our platinum that we dissolved in Aqua Regia in this beaker. So now what I'm going to do is I'm going to add a little bit of hydrochloric acid. Now I'll cover the beaker. You can see the precipitate is in there with the other solution. Now what I'll do is add some nitric acid to form Aqua Regia in there. Not very much. There's 3 milliliters. Let's put in about 6 milliliters and see if that does it for us. Now let's set this up on the heat back here and start dissolving that precipitate on low heat. If you look over here, this is our mixed black PGM powders from the Silvercell anode filters refining. We're starting to pull some palladium out of there. Palladium is the only metal of the 6 sister metals in the platinum group that's soluble in nitric acid alone. However, some of the platinum, since it's in a finely divided state in there with the palladium, some of the platinum will go into solution with this gentle nitric acid boil as well. Here's our precipitate that we've added to the speaker. I put some Aqua Regia in there, added some low heat, and now we're going to try to dissolve this metal. This is going to have a little copper in it too. You've seen the green material that was in there with it. That's from the copper, and what we'll need to do is try to get the copper out of here before we proceed. I think I've got all this to go into solution now. With the Aqua Regia, it's just going to be a little bit of filter paper left down in here. Let's pull it down, let it cool off. And then over here, this is complete. There's no more fumes in there. You can see it looks like coffee. It's probably going to be some palladium. We'll put this down here and let it cool off and figure out what to do next. I am not a platinum refiner, and I'm making this up as I go, learning as we go. All right, let me reach down in here with a piece of filter paper on a bamboo skewer and get a little bit of this solution on a piece of filter paper. Let's test it with stannous, just see what we got going on. I'm expecting platinum here. And we've got a dark stain, orange and brown. So it's probably a mixture of platinum, palladium, and gold in solution. This solution came from our filter papers refining. This comes from the anode, Silvercell anode filters refining videos. I'll reach down in here with a little piece of filter paper, get some of this solution. Do a stannous test on this, see what we've got. And that is a dark brown stain. I can see some green in it and some orange, so that tells me we've got platinum and palladium in this solution. As I said earlier, this solution right here, or this group of metal right here, we put dilute nitric in here and heated it gently. It's going to be mostly platinum and palladium in here. Palladium is soluble in nitric acid. Platinum is not. However, by putting dilute nitric in here, we're going to be pulling some palladium out of here, mostly palladium, but a little bit of the platinum is going to dissolve with it also. Conversely, we can't get all of the palladium pulled out with the nitric boils. Some of the palladium will remain in the black mixed PGM powders down here. That's going to be platinum. You can never get a 100% separation of these two metals. It's just impossible. That's the nature of platinum group metals. Back here I have my two solutions. This is from the filter papers. This one is from the anode, silver cell anode filters, mixed black PGM powders. Up here I now have the black mixed PGM powders from the stock pot. Here I have the nitric acid treatments from those mixed black PGM powders. It's got a little bit of platinum group metals in it, but it also has copper in it. So what I'm going to do is I'm going to add this straight back into the stock pot now, and we'll cement any platinum group metals out of this solution in the stock pot in the copper that's in there. Here I have the copper from the nitric acid boils that we did on the mixed black PGM powders and gold from the stock pot down here. I've collected that in this flask. We're just going to pour this right back into our stock pot now and cement out any precious metals that may still be in this solution. Let me cover this up and get this down out of the way now. Let me pull these two beakers down out of the way. Now what we'll do is pull the water out of this beaker. It's got our mixed black PGM powders in it. Just going to draw it off one drop at a time. Get it out of here. I've drawn off the clear water off of our mixed black PGM powders, and here's what the material looks like now down inside the beaker. Now what I'll do is add some hydrochloric acid to the black powders from the stock pot here that we've cleaned up. Got all the copper removed out of it. I'll put about 200 milliliters of hydrochloric acid in there. I'm setting the black PGM powders, gold, and hydrochloric acid mixture up on the heat now. I'm going to turn on some low heat with it. Now what I'll do is add some nitric acid to the hydrochloric acid and mixed black PGM powders in this beaker. We'll start dissolving this material with Aqua Regia. That's about 9 milliliters of hydrochloric acid, or nitric acid rather, to form Aqua Regia in there. And now let's put this material in solution. Okay, I think I've got all of the material here to go into solution. So we're going to pull this down now and let this cool off and go from here. I think this is a convenient place to conclude part one. I think we pretty much got everything in there dissolved. This is the mixed black PGM powders from the stock pot, number 4. It's also going to have some gold in it. We've removed all the copper, so we got an advantage here. We got the copper out of here first. Over here then I have the mixed black PGM powders from the silver cell anode filters, and we've hit that with some nitric acid. And I don't see a whole lot of green color going on in there, so we may have all of the copper removed from here as well. And then over here, last but not least, we've got the platinum salts and a little bit of mixed black PGM powders that we've dissolved in Aqua Regia from the paper filters recovery video that I did. I precipitated out the platinum from that video and I saved it, and I didn't have enough to do a complete refining. So now I think that with these 3 solutions combined, we should have enough to do a complete refining and get some platinum group metals. And this will conclude part 1 of the Stockpot 4 platinum refining video. We'll pick this right back up in part 2. Thank you for watching.